Thank you very much for that wonderful introduction. It probably made my mother very proud. And the ambassador asked me to talk today about triumvirate of factors, namely the academic world, government, and industry. And so I shall. And initially, the Hebrew University did not collaborate with the government nor with industry for a very simple reason. It didn't exist. The Hebrew University was opened 30 years before the country was established. It was opened by these gentlemen, and I'll name them from right to left: Albert Einstein, Sigmund Freud, Martin Buber, Chaim Nachman Bialik, Israel's poet laureate, and my favorite on the left is Chaim Weizmann because he's a biochemist like myself. It was opened by these gentlemen in order to provide the fledgling nation with a technological, cultural, and scientific background in order to establish the State of Israel. Today, the Academy in Israel in general, and the Hebrew University in particular, strongly collaborates both with the government and the industrial sector. The reason is because they entrusted us in order to be the engine that propels the Israeli economy, or one of those engines. So the Israeli government is very supportive in providing numerous vehicles to support research on a variety of different levels, depending how advanced your particular technology is. The first thing that we base our success is on research excellence, first and foremost. And this is research excellence that is manifested in Nobel Prizes, in field medals, in Turing Awards, etc. And a nice number to remember, to keep in the back of your mind, is that in the last decade and a half, in only 15 years, 7 graduates and or alumni of the Hebrew University have won a Nobel Prize. So that demonstrates basic research excellence. But the important thing that we have recognized in the Hebrew University and in Israel in general is that we don't necessarily differentiate between basic research or applied research. We differentiate between good research and bad research. This, of course, is a demonstration of basic research excellence, Nobel Prizes, etc. But we also encourage applied research excellence. And that's the examples that I want to give you today. I want to give you examples in which the Hebrew University collaborated with industry via technology transfer in order to generate products for the public. It's not necessarily to say that the humanities, social sciences, law, etc. are not important. I would argue that they are vital for the success of the university. But in order to convince the public of a value of the university, you have to give them tangible evidence, things that they use on a daily basis. And that's the examples that I want to give you today, because I think that I can talk about schemes and I can give you statistics, etc., and everyone would fall asleep. The best way to demonstrate how we work together with government and with industry is to show you examples. And the last point that I want to give you is, it's critical not to focus on one particular field. Okay? Israel about 10, 15 years ago was always criticized that we don't have a unicorn company, let's say like Nokia in Finland. Why don't you have a multi-billion-dollar company? Well, look where they are today. Okay? What we do is we try to provide a broad base of research excellence, and because of that, I will give you examples of 4 different fields in which we have impacted the world. Computer science, which you see right in front of you. I'll talk about material science, medical science, and agriculture. And the first example, of course, I don't want to steal the thunder of the next speaker to come, which knows about Mobileye much more, and he will give you more examples. What I want to tell you about Mobileye, which is a company which was established by Professor Amnon Shashua, is the university aspect. The university decided to enable Professor Shashua to establish this huge company because it recognizes that the importance of this research is exactly what the university is striving to achieve. It saves lives all over the world. It provides a place of employment for hundreds upon hundreds of families in Jerusalem, and it gives our students, first-year students in computer science, the example of what computer science can generate. So in our respect, this is exactly in line of the mission of the Hebrew University. That's Mobileye coming from the Hebrew University, Professor Shashua. Another example is what we're surrounded with daily, and that is video surveillance cameras. They're very, very cheap to implement. And the problem is that no one has the patience to look at the hours upon hours of video data that they generated. In fact, someone has estimated that more than 90% of all the hard drives in the world are filled with video data that no one has the time to look at, because you can't just click fast forward. It doesn't work. So Professor Shmuel Peleg, another member of our computer vision department, like Professor Shashua, generated a company that won the Wall Street Journal Best Technology Award a few years, that what it does, it generates a video synopsis. So what you see on the left is the original video. Here it's 30 minutes. What you see on the top, on the right, is the synopsis, 20 seconds. Here it's 41 seconds. What it does, it transposes all of the events one on top of the other. You see this in real time. It's not running faster than what your eyes can measure. All you need to do is to look at this video, click on the object, on the event of interest, and then it expands normally. Now you ask yourself, is this just an application that some computer scientist has done without much utility? Well, I wouldn't be showing you if that was the case. Numerous security agencies all over the world utilize this technology, and perhaps the best example is the CIA and FBI in the US that have used this technology in order to capture the bombers of the Boston City Marathon only 3 weeks afterwards. Why? Because they were able to survey the tens of thousands of video hours within hours using Shmuel Peleg's technology. So, moving quickly to another field, because again, as I stress, it's important to spread yourself broadly so you'll be able to meet the challenges of the future. Material science, and what we have here is Professor Uri Banin. And what Professor Uri Banin is doing is try to manipulate the spectrum of the most efficient light source in the world, and that is LED. Normally, LED is very white, and the moment that we try to manipulate its light source, we lose efficiency dramatically. So why use LED in the first place? Well, what Professor Banin, using high-scale advanced technologies, quantum dot technologies, for which he has an ERC advanced grant of close to 3 million euros, was able to manipulate LED light without any loss of efficiency. The company was sold to Merck, the chemical giant from Germany, and the Hebrew University, recognizing the importance of the commercial sector, decided to allow Merck to stay within the campus of the university, despite the fact the company is wholly owned by them. Why? Because we recognize that that is one of the things that we need to do, and it brings our students closer to industry. Another example of material science comes from a slightly different area, perhaps from the agricultural world. On the right, you see Professor Oded Shosayov, and what you see here are two chemicals. The chemical on the right is one of the cheapest chemicals in the world. In fact, it's so cheap that the paper industry gives you money to take it away from them because it's their waste product. It's from the paper pulp industry. Why is this material so cheap? Because it has very poor mechanical properties. As you can see, it's purely plastic. It does not retain its shape. However, on the left, what you see is a material that was infused with something, and I'll tell you exactly what that something is, and it has wonderful elastic properties. It returns to the same shape. In fact, the material on the left is lighter than rubber and more elastic than rubber. And that's exactly why this company called Fulcrum, which was established with funding from the chief scientist from the government, already has contacts with companies such as Nike or Reebok in order to put that on the soles of the shoes. So you ask yourself, what material did they infuse? Well, Professor Shosayov looked for the most elastic component in nature, and believe it or not, it comes from fleas. Fleas jump higher relative to their size than any other organism on Earth. If we had the jumping capacity of fleas, we will be able to jump higher than the Empire State Building. So he genetically engineered tobacco to express this flea protein, infuse that into the waste from the paper pulp industry, and you have material that is better than rubber in terms of elasticity and weight. Moving to a different field altogether, medicine, and one of the biggest success stories that we have is by Professor Martha Weinstock-Rosin. This tiny little pill that she holds in her hand over there sells for over $1.3 billion every year. The reason that I use that number is not necessarily to impress upon you that Professor Martha Rosin is very wealthy. The reason that I use this number is to impress upon you the impact of basic research excellence all over the world. Clearly, it's not just members of Jerusalem or Israel that are buying this pill that is treated for the dementia that one suffers in Alzheimer's or Parkinson's. This is sold all over the world, stressing the impact of how basic research excellence that can convert into applied research excellence has all over the world. Another example, let's see, wonderful. Another example is what we're doing to treat Parkinson's. This is Professor Chagai Bergman, and you see two videos, hopefully. You see a gentleman on the top that looks perfectly normal, and you see a gentleman on the bottom that is exhibiting severe Parkinson syndromes, unable to do very simple gestures such as this, unable to resist being pulled at all. The amazing thing is that the difference between those two videos are 2 weeks in deep brain stimulation. It's the same person. It's the same person being treated by Professor Chagai Bergman in our hospital using deep brain stimulation, 2 electrodes that are inserted in your brain, and as you can see, nearly rectify completely the symptoms that one has from Parkinson's. So this is truly revolutionary. We've done several hundreds of these. Now moving to a different and last field, I don't want to leave you with pictures of people suffering from Parkinson's or Alzheimer. I want to leave you with pictures of the agriculture, again showing you the broad-based technology transfer activity that we have. And our biggest claim to fame, no doubt, are cherry tomatoes. As you can see, Professor Chaim Rabinovich on the right, and to his left, Professor Nachum Kedar, invented, if you will, the cherry tomatoes. 25 years ago, none of you ate cherry tomatoes. For the very simple reason that their shelf life was measured in hours. So from the time the farmer picked the cherry tomato until the time that you could eat it was less than several hours because they ripened too quickly. Professor Nachum Kedar realized the problem and then was able to crossbreed this with strains of tomatoes that never ripen, resulting in what you see today. Every single cherry tomato that is sold all over the world is a result of this product. It also generated the Israeli seed industry that was later on bought by Syngenta and Monsanto. And it's interesting to note, by the way, that per weight, seeds of cherry tomatoes cost more than gold. Okay, so a kilogram of cherry tomato seeds is about $60,000 as opposed to gold, which is about $30,000 to $40,000 depending on the price of gold. And something slightly more recent, there we go, okay. This is Tzvika Peleg on the right, and what you see on the left is how everyone in the world is harvesting sesame. Here in Greece, as well as in Israel, we love sesame. It's considered a superfood. Sesame has one of the highest contents of both iron as well as calcium and protein in the non-animal world. It really is a superfood. But the problem with sesame, as you can see, it is harvested by hand. Every single sesame seed that you eat was cut by hand, not by a machine. And why is that? The pods of the sesame plant open the moment that they ripen. Okay, so if you come with a machine and you try to harvest that, the seeds fall on the ground, and that is a problem. Professor Tzvika Peleg realized that this is a tremendous problem, both in terms of efficiency and cost, and he was able to generate varieties of sesame. This is not GMO, this is not a genetically modified organism, this is standard breeding, and he was able to generate something that seems quite remarkable. If you're a sesame seed farmer, this to you looks unimaginable. This is the first ever mechanical harvesting. This was only done 6 months ago of sesame seeds, a pod that remains closed despite the fact that it is completely ripened. Okay? So this is quite exciting for us. Hopefully this will be the next blockbuster after cherry tomatoes. So I'll finish with those examples. Those are just the tip of the icebergs, as you see over here. I haven't talked any about all of the other topics that we do in Israel, but it's important to recognize again the 3 following facts. First of all, collaboration with government is critical because they provide support for traversing the valley of death in application. Recognition that basic research excellence and applied research excellence are the same. And finally, developing several different fields at the same time and not putting all of your eggs in one basket. And lastly, I want to thank you for the kind invitation, for the minister who has left and our ambassador. It's wonderful to be here with you and to see all of the exciting things that are taking place. Thank you very much.